Good morning, students. Thank you for joining my class today. Let me introduce myself. My name is Miss Santi Setiasri Rejeki. You can call me Miss Santi. I'm gonna teach you for Indonesian model subjective chemistry. The first chapter that we are going to talk about is the study of matter. As you know, when you are in junior high school, you have already known that matter is anything that has mass and occupies space. And you have already known also that matter has three states. They are solid, liquid, and gas. Solid, liquid, and gas, they have different properties based on the distance of particles. Solid, the particles are very near to one another. Liquid, the particle is not too far from one another. And then gas, the particles is very far between one another. That's why solid, liquid, and gas, they have different properties. The properties of the solid gas is they have definite volume, they have definite gas, and also they cannot be compressed, and the rate of the diffusion is very slow. And then liquid, they have indefinite shape, but they have definite volume, and the rate of diffusion is slow. But gas have indefinite volume, indefinite shape, and but the rate of diffusion is very fast comparing to solid and liquid. Matter can undergo two types of changes. The changes that happens in matter are physical changes, and the second one is chemical changes. Physical changes is changes occur without a change in the composition of the particular substance. But chemical changes that happens in a matter and produce new substance with different composition comparing to the old matter. Now, the examples of physical properties here you can see in the slide. I will give you some. They are conductivity. The conductivity are two: electrical conductivity, thermal conductivity, malleability, strength, hardness, density. And the example of the chemical properties changes, they are reaction with oxygen, water, acid, bases, and any specific reaction with other substances. As you can see in this slide, there is a physical changes examples. Take a look. When water is heated, it will be water vapor. But the composition of water, it is still the same with water vapor since they consist of water molecule. So it means that water still consists of water molecule, and water vapor still consists of water molecule also. Example of chemical changes here is methane. When methane is reacted with oxygen, it will form new substances. What are the new substances formed? They are carbon dioxide and water vapor. Since this kind of reaction produce new substances, that's why that reaction belongs to chemical changes. Classification type for matter can be seen in this slide. Matter is classified also into two types. The first one is pure substances. The second one is mixture. Pure substances, it means that that substance is homogeneous and they have fixed composition. Pure substances, there are two types of pure substances. The first one is element. Elements is a simple substance that cannot be separated by chemical means. And also the second one is compound. Compound is substances that still can be divided by using chemical means, but they have fixed composition. The example of element here, as you can see in your periodic table, they are carbon, copper, oxygen, magnesium. And the example of compounds are water molecule, carbon dioxide, methane. Those are the example of compound. I already told you before that pure substances, they have fixed composition, but it's different with mixture. Mixture has different or variable composition. Mixture also are divided into two types. The first one is homogeneous mixture. The second one is heterogeneous mixture. Homogeneous mixture, it means that the mixture are uniform. The example is sugar solution. Heterogeneous mixture, the mixture is not uniform. The example is soy sauce, seawater. Those are heterogeneous mixture. can be separated with some techniques. They are distillation, decantation, filtration, crystallization, and the last is chromatography. Let's focus on distillation and also decantation. Distillation is the process separating mixture into some component based on the boiling point of the component of the mixture. And decantation is the process to separate mixture by removing liquid layer or solid from the solution. As you can see in the periodic table, you can see many kinds of elements. It is estimated there are 109 elements on the earth, and you will find out that 89 elements they happen naturally. Now, usually the symbol of the element comes from the first letter of the names of the element. In this slide, you can see the example of the element that their symbol comes from the first letter of the name of the element. They are hydrogen. The first letter of the hydrogen is H. That's why the symbol of the element is H also. Nitrogen. The first letter of the nitrogen is N. That's why the symbol of the element is with capital letter. It is N. There are some of the elements that their symbol consists of only one letter. But there are also some of the elements that their symbol consists of two letters. If the symbol of the element consists of two letters, it means the first letter should be capital letter and the second letter should be lowercase. The example here is aluminium. Aluminium, the symbol consists of two letters. They are A and L. Calcium. Calcium, the symbol consists of two letters. They are C and A. As we have already discussed before that element is a basic substance of matter, but compound is the combination of elements. But there are some questions also that we cannot answer. They are, how is one element different from another element, and how does the compounds form, and how is compound different from the mixture? To answer these three questions, we need to understand about atomic theory, which has been proposed by some scientists. The first atomic theory that we need to learn is the law conservation of mass. The law conservation of mass tells that total mass before reaction is equal to the total mass after reaction. For example, if you have 0.024 magnesium burned with 0.016 oxygen, the result will be, you just need to add 0.024 plus 0.016 become 0.041 magnesium oxide. The second law of chemistry is the law of constant composition. The law of constant composition tells us that all pure samples of the same compound contain the same element combined together in the same proportion. Take a look here as the example. 100% of pure water will have 88.9% of oxygen plus 11.1% of hydrogen. So if you have 100% of 100 gram, if you have 100 gram of pure water, it will have 88.9 gram of oxygen and 11.1 gram of hydrogen. But if you have 200 gram of water, so you just need to multiply the percentage by 2, so you will get 88.9 times 2 become 177.8 gram of oxygen, and about the hydrogen is 11.1 gram of hydrogen times 2, it will be 22.2 gram of hydrogen. The third law of chemistry is the law of multiple proportion. The law of multiple proportion tells us that in different compound containing the same two element, for example, element carbon and element oxygen, there is a simple whole number ratio between mass of one element which combined with a fixed mass of other element. For example, carbon and oxygen. Carbon and oxygen can be combined chemically to be carbon monoxide, carbon dioxide. But carbon monoxide and carbon dioxide, they have a different ratio of mass between two elements. For example, carbon monoxide 12-gram carbon monoxide, if it is reacted chemically with 16 gram of oxygen, it will be carbon monoxide. But 12 gram of carbon, when it is reacted with 32 gram of oxygen, they will form a different compound, which is carbon dioxide. Early 19th century, John Dalton proposed concept of atom that explain briefly about atom, and this kind of theory based on his experiment, and the theory is called Dalton atomic theory. The first Dalton atomic theory is element consists of extremely indivisible small particle called atoms. The second is all atoms of the same elements are identical, so all atoms in the elements of gold, they are all identical. The third, atoms of different elements are different in properties. So atoms of element aluminum will have a different properties with atoms of elements gold. 4. Compounds are from when atom of more than one element combine. The same compound have definite and constant relative number of atoms. 5. Combining in different ratio, atoms of two or more elements may form more than one compound. So for example, carbon and oxygen, when they form compound, it could be two compounds. The first one is carbon monoxide, the second one, it could be also carbon dioxide. But the ratio of carbon and oxygen in carbon monoxide and carbon dioxide, they are different. But there are some of scientists that they revised Dalton atomic theory based on their experiment. So there was a modification of Dalton atomic theory. The first modification of Dalton atomic theory is in Dalton atomic theory, it is said that element consists of indivisible atom, so it means that atom cannot be divided anymore in Dalton theory, but it was modified to be atom still can be divided by splitting with a high energy particles bombarding, and atom also can disintegrate spontaneously by radioactive decay. And then the second one, it is said in Dalton atomic theory that atoms of the same element, they will have the same properties, but element may exist as different atomic form. So it means that element, they may have different element, they may have different masses. For example, carbon 12, it means that carbon has the mass of the carbon is 12, and carbon 14, the mass of the carbon is 14. Let's discuss about structure of the atom. In Dalton atomic theory, it is said that atoms cannot be divided anymore. But then there was some scientists modified that kind of theory. So today's theory become atom consists of three subparticles. They are proton, electron, and neutron. Proton, it has positive charge. Electron, it has negative charge. And neutron, it is neutral. And the mass of proton is similar to the mass of neutron, which is 1.673 times 10 to the power of minus 27. But electron is the lightest, and its mass is 9.110 times 10 to the power of minus 31. Atom can be visualized in two main regions. They are nucleus and also orbit. Now, let's talk about nucleus at the first. Nucleus contain two kinds of subatomic particle. They are proton and neutron. Proton, it has positive charge, and neutron, it is neutral. And nucleus cover 99.9% of the mass of a whole atom. But if you compare the diameter of atom and the diameter of nucleus, the diameter of nucleus is very small comparing to the diameter of the atom. Second main region of the atom is orbit. In the orbit, we can find that electron moves around the orbit by using electrostatic force between proton and electron. Atom, it is called also as electrically neutral. Why it is called as electrically neutral? Because of the number of proton and the number of electron of the atom is the same. So the positive charge of the proton will cancel all the negative charge of electron, so it will be neutral. Second main region of the atom is orbit. In the orbit, we can find that electron moves around the orbit by using electrostatic force between proton and electron. Atom, it is called also as electrically neutral. Why it is called as electrically neutral? Because of the number of proton and the number of electron of the atom is the same. So the positive charge of the proton will cancel all the negative charge of electron, so it will be neutral. The of the atom is conveniently described with two numbers. The first number is atomic number, the second one is mass number. Atomic number is symbolized with Z and mass number is symbolized with A. And the symbol of the element is symbolized with X. If the atom is neutral, you will find out that the number of proton is similar with the number of electron. But if it is negative ion, the number of electron will be more than the number of proton. But if it is positive ion, the number of electron is less than the number of proton. Let's count the proton number, electron number, and neutron number of fluorine element. The atomic number of fluorine element is 9. The mass number of fluorine element is 19. To get the proton number is similar with the atomic number. If the atomic number is 9, it means that the proton number of fluorine element is also 9. But if the electron number is similar with proton number. So if the proton number is 9, it means that the electron number is also 9. But it's different with the neutron number. To get the neutron number, we need to subtract mass number minus atomic number. So 19 minus 9 is going to be 10. So the neutron number of the fluorine element is 10. All atoms of the same element, they must have the same number of proton. But all atoms of the same element, they do not necessarily have the same mass. It is all the elements that they have different mass. That's what we call with isotope. For example, here is oxygen. Okay, there are oxygen that has mass number of 17, and there are also oxygen that has mass number 18. Now, oxygen that has mass number 17, it is usually identified as oxygen 17. Oxygen that has mass number 18, it is usually identified as oxygen 18. Classified into three groups according to the arrangement of the atoms in its element. The first one is metal. Metal is represented by its chemical symbol as its formula. The example here is iron. Iron is represented by its chemical symbol Fe as its formula. The second one, covalent molecular elements. Covalent molecular elements means atom join together with another atom by sharing their valence electron. The example here is hydrogen gas and also oxygen. The third group is covalent network element. Covalent network element means that atom join together with another atom by using covalent bonding in a continuous network through the material. These are the example of element that bonding together with another element by using covalent network bonding. They are diamond and also graphite. Okay, that's it for the lessons today. I hope that you can understand the lesson, and you are free to ask me if you have any questions so far related to the lesson. Thank you and goodbye.